And Y in figure denotes OC and full load test. Okay, this is curve X, OC test. This is curve Y, ZPF, characteristics of an alternator. Now Q is a point on ZPF characteristics at voltage 1 per unit. The vertical distance in figure gives a voltage drop across. Okay, many people think that Portier reactance, but that is wrong answer here. Now what is Portier reactance here? If you have full load ZPF, okay, this is OCC characteristics. If this is SCC, not SCC, ZPF characteristics. Now what is Portier reactance? Portier reactance is nothing but, now let us take this as a point of intersection. This gives a Portier reactance. Okay, distance between this one and this one. Okay, but this is not exact Portier reactance. Okay, there will be one more curve. You will get like this, small distance. Okay, this is the exact Portier reactance. Okay, if you follow true characteristics of ZPF and OCC, you will get these answers. Okay, this is not leakage or Portier. Since this is perpendicular to x-axis and parallel to y-axis, what does it mean? That is nothing but an magnetizing reactance. So option B is correct answer.
The constant M circle represented by the equation x square plus 2.25x plus y square, which is equals to minus 1.125, where x is the real part of the open loop transfer function and y is the imaginary part of the open loop transfer function. Find out the value of m. Here x plus 1.125 square plus y square is equals to 0.140625. So the equation which is given in the question, we can modify it to this kind of equation. So if we compare this equation with the standard M circle equation, that is x plus m square minus by m square minus 1 whole square plus y square is equals to m by m square minus 1 whole square. So m square divided by m square minus 1 is equals to 1.125. So m square minus m square 1.125 is equals to minus 1.125, which is minus 0.125 m square minus 1.125. So m square is equals to under root 1.125.125, which is equals to 3. Hence option C is correct. System given below, the feedback does not reduce the closed loop sensitivity due to the variation of which one of the following. Here we know that the closed loop sensitivity, suppose I am indicating with M, which is 1 plus G of S H of S, which is nothing but 1 by Ka by S plus alpha. H of S is beta, hence 1 by, that is S plus alpha by S plus alpha plus Ka beta. Here beta, suppose if K is varied, A is varied, beta is also got multiplied to that particular factor, which will reduce the closed loop sensitivity. But if we increase the alpha, which is not going to affect the closed loop sensitivity, because if we increase the alpha, the numerator portion is also got increased, so the sensitivity is not going to be affected. Hence option C is the correct one.
Range of inductance for a moving iron ammeter is 2 microhenry per degree. The control spring constant he has given as Kc, which is equal to 5 into 10 power minus 7 Newton meter per degree. The maximum deflection of the pointer is 100. Okay. Theta is equal to 100 degrees. The current corresponding to maximum deflection is. Here the type of instrument he has given is moving iron ammeter. Okay, for any instrument we know that the controlling torque should be equal to deflecting torque at steady state. Okay, otherwise there is no control torque. What happens? The deflecting pointer which will read the maximum value of the meter. Okay, for every meter at steady state, controlling torque should be equal to deflecting torque. We know that controlling torque is given as Kc into theta. Now deflecting torque for moving iron ammeter is given as 1 by 2 I square into dl by d theta. Okay, in question he has given dl by d theta value as 2 microhenry per degree. Okay, now substitute the values to find the value of current corresponding to maximum deflection. Kc is 5 into 10 power minus 7. Theta is given as 100 and which is equal to 1 by 2 into I square. dl by d theta is 2 microhenry per degree. So this is 2 into 10 power minus 6. Okay. Now this is equal to I square is equal to 50. From this we can find I as 7.07 amperes. Option A is correct answer. 5 volts DC supply is connected across a resistance of 600 ohms in series with an unknown resistance Rx. Okay. Now let us draw the diagram of this one. Let us take this resistance as unknown resistance Rx. Okay, it is connected in series with 600 ohms. So the resistance of this one is 600 ohms across 35 volts DC supply. Okay, now a voltmeter having resistance of 1.2 kilo ohm is connected across this 600 ohms resistance. Okay, now there is a voltmeter here which is connected across this one of 1.2 kilo ohm. Okay, and this voltmeter reads 5 volts. The value of resistance Rx will be. Okay, we have to find what is this value of Rx. Okay, now I can write R equivalent from this one is V by I. Okay, the R equivalent whatever present in this circuit. Okay, this one. R equivalent between these two terminals. These two terminals I am taking it as R eq. I can write this one as equal to V by I. So this is equal to 35 by, I am taking resistance to this one is IR and current flowing through 600 ohms is IR and current flowing through voltmeter is IV. Okay, now what is the total current I here? Summation of IR plus IV, which is equal to 35 by, now what is the voltage across these parallel branches, these two parallel branches? 600 ohms, and this voltmeter is having 1.2 kilo ohms resistance. He has given as voltmeter reading which is equal to 5 volts. So I can write IR as 5 by 600 plus IV as 5 by 1.2 kilo ohms, or you can write it as 1200 ohms. Now if you simplify this one, you will get it as around 2800 ohms. Okay, now this is not our objective here. We have to find Rx. Okay, we know that R equivalent is equal to, I can write this one as Rx plus, okay, 600 ohms, that is the parallel resistance connected across the voltmeter is in parallel with 1.2 kilo ohms, which is resistance of voltmeter. These parallel combination and in series with unknown resistance Rx, which is equal to, we found it as 2800 ohms. If you simplify this one, you will get Rx as 2800 minus 400, which is equal to 2400 ohms. That is equal to 2.4 kilo ohms. Option D is correct answer.